Hi students, this is Shiva. You are watching Maths YouTube channel Maths Insights. Today's topic is very important. What are meant by elementary operations or transformations of a matrix? This is very important topic in matrices. See, what is meant by elementary operation? There are particularly 6 operations, 3 of which are row operations and 3 of which are column operations. By using these operations, you can transform any matrix to any other matrix to make our calculations very simple by transforming into simpler matrix. So I am going into this discussion. There are 6 operations. Okay, 3 row operations or transformations, another 3 are column operations. So question arises, why these are operations? As I said, to make the calculation very simple. The first operation, you can interchange any row with any other. Similarly, you can interchange any column with any other column of the matrix. Suppose interchanging of this rule is called interchanging of ith row, okay, with jth row, or ith column with jth column. See, generally students are using small j as denoting the column number, but here j is not column number here or column number here also. See, this I and j are using to differentiate 2 rows, and are here I and j are using to differentiate 2 columns. For example, I am taking A is equals to 1, 2, 3, 4. I am taking a square matrix to simplify it. In this case, we will denote Ri double implies to Rj, or Ci double implies to Cj. Means you may interchange Ri with Rj or Rj with Ri. I am writing double implies means this operation will apply on both ways. So by taking an example for this, it will clear very easily. That means here in this case I want to interchange R1 and R2, means I may write R1 double implies to R2. So after interchanging row 1 with row 2, means row 2 becomes row 1, okay, row 1 becomes, row means the horizontal arrangement, column means vertical arrangement. This row 2 becomes row 1, and this row 1 comes into the place of a row 2. In the similar manner, if you take the same matrix 1, 2, 3, 4, if you want to apply column transformations, so you may interchange C1, means column 1 with column 2. That means what happens? This is column 1, this is C1, this is C2. Horizontal vertical arrangement of numbers. See, C2 comes in the place of C1, 2, 4, and C1 comes in the place of C2. In this way, you may transform a given matrix by using this rule. Second operation is multiplication of elements of any row or column with non-zero constant. Let that constant be k. This can be written as, suppose Ri, that means ith row. If you multiply the elements of this ith row with a constant k, you can write this operation as k into Ri. You have to write only one way. Why? Because you are transforming this row only, not this is transforming as this one. Similarly, Ci can be written as k into Ci. You can better understand this by taking an example. I am taking a 3 by 3 matrix. You can apply the operations on A also. That means if A is either square or rectangular, 1 2 3 4 5 6 7 8 9. This is a 3 by 3 square matrix. In this matrix there are 3 rows and 3 columns. What I am doing here is I am multiplying the elements of row 1 with a non-zero constant 3. Let 3 constant value. Then R1 implies to 3 into R1. Other rows are unaltered, that means intact. So whatever changing, concentrate on it. 3 into R1. 3 1s are 3, 3 2s are 6, 3 3s are 9. So remaining elements you may write as it is, you have to write as it is. 7, 8, 9. So in this way you can multiply elements of any row with a non-zero constant. Similarly, if you want to multiply the second column with a non-zero constant, let 2, that can be written as C2 implies 2 into C2. So what are unaltered, what are unchanged means C1 and C3 unchanged. First write them 1 4 7. Only C2 is changing. You are multiplying the elements of column 2 with the non-zero constant 2. 2 2s are 4 and 2 5s are 10 and 2 8s are 16. And you are not altering the elements of column 3, so writing as it is. So 3 6 9. This is the transformation. This is the second transformation. You may do this in either in columns or rows also. The third transformation is very important, the addition to the elements of any row or column. You can add the corresponding elements of any other row or column by multiplying with non-zero constant. This may little bit be confused, but it's very easy. You have to add elements of other row or column by multiplying with a non-zero constant. Then you can write it as, suppose I am taking R1, that can be written as Ri. I am taking ith row. To the elements of ith row, I am adding the elements of jth row by multiplying with a non-zero constant, let k. So this is the third transformation. Ri implies to Ri plus k into Rj. Similarly, Ci is equals to, you are adding to the elements of Ci, column I, by multiplying the elements of jth column by multiplying with a constant called k. This will become very clear if you take an example. I am taking a matrix, let it's 1 4 5 2 6 9 minus 2 4 8. This is I am taking 3 by 3 matrix. Now what I am doing here is, to the row 1 I am adding the elements of row 2 by multiplying with 2. That means 2 into R2. This means what happens? R1 implies to R1 plus 1 plus 2 into R2. 1 plus 2 into 2. 2 into 2 is 4. 4 plus 1 is 5. Next, R1 plus 4 plus 6 into 2. 6 to is 12. 12 plus 4, 16. Next, 5 plus 2 into R2. 9 to is 18. 18 plus 5 is 23. And remaining rows R2 and R3 are unaltered. Therefore, you may write them fastly. Wherever operations are to be done, be slow there. Take care. Whenever simple addition or subtraction goes wrong, then entire problem will goes wrong. So operations are there. Be careful whenever in which any other rows operations are not there. You may go fast. -2 4 8. So this is the matrix after transformation. Similarly, if you add to the elements of C1 the elements of C2 by multiplying with a constant 2 into C2, then what happens? which one is altering here? C1 column 1, so be careful. So 1 plus 2 into 4, 4 2 is 8, 8 plus 1 is 9, so you are going in the first column. So 2 plus 2 into C2, 6 2 is 12 plus 2 14. Next and last one is C1 minus 2 plus 2 into C2, 2 into 4 is 8, minus 2 plus 8 plus 6, and remaining columns are unaltered, therefore you may write fastly them. Okay, 5 9 8. This is the matrix after transformation by using the third transformation rule. In this way, by using these three transformation rules on a matrix, you may transform it to other matrix. The first one is you may interchange any row with any other row, and also any column with any other column. Second one says you may multiply the elements of any row with a non-zero constant. Similarly, elements of any column with a non-zero constant. The third is important. You may add to the elements of any row the elements of any other corresponding row by multiplying with a non-zero constant, which may be written as Ri implies to Ri plus k into Rj. Similarly, Ci means if you want to add to the elements of any column by multiplying any elements of other column with k, this will become the third transformation. I am taking a question to give you a better understanding, better view on all these transformations. Transform 2 3 1 2 into a unit matrix. This is a 2 by 2 matrix. Unit matrix, 2 by 2 unit matrix means I is equals to 1 0 0 1. So our aim is to transform all these elements like this. We have to use all the transformation rules. See, the first one, in this case I want to get 1 here, but in this case there is no 1, so I will interchange row 2 with row 1 or row 1 row 2. So row 1 double implies to row 2 means row 2 can be written as in the place of row 1, 1 2 2 3, right? Next, the second transformation, I want to get a 0 here. If I want to get 0 here, I have to subtract elements of R1 by multiplying with the 2. 2 minus 2 into 1 becomes 0. Therefore, in the place of R2, what I am doing, R2 minus 2 into R1. I am using the third transformation rule, that is R2 in the place of R2. So R1 is unaltered. I am writing as it is, R2 minus 2 minus 2 into R1, 2 minus 2 0, R2 minus 3 minus 2 into 2, R2 means 3, 3 minus 2 into 2, so 3 minus 4 is minus 1. So I use two transformation rules. Next one is, what is my aim? I want to get 0 here, and here I want to get plus 1, means in the place of R2, what I am doing is I am multiplying with minus 1 into R2, that implies 2. So row 1 is as it is, 1 2. See, if you multiply 0 with minus 1, you will get 0 again. This is minus 1 into minus 1 will become plus 1. I am approaching to this matrix. Here the difference is only 2. So to get 0 here, I have to subtract the elements of R2 by multiplying with 2. I am writing here, therefore R1 implies 2, R1 minus 2 into R2, 2 into R2. Therefore this 1 minus 0 into 2 again becomes 1. Next, R1 2 minus 2 into 1 0, and R2 is unaltered 0 1. So I got the unit matrix. In this way, you can transform a matrix into simpler matrices to make the calculations very easy. Next is, what are meant by equivalent matrices? Why? Because this is related to these transformations Hence I am explaining in this video itself. Equivalent matrices means if a matrix is transformed into other matrix by using row or column matrices, then the resultant matrix, whatever you will get, that matrix is called equivalent matrix to the original matrix. So in this case we named it as A. Suppose if you name it B, after applying the elementary or row operations in this matrix, you obtained that these two matrices are said to be equivalent matrices. We can write it as A is equivalent to B. So after transformations, whatever the result, those matrix is said to be equivalent to first one, or first one is said to be equivalent to second one. So these are the elementary row operations or column operations. These are very useful. We will deal with these operations in the next coming videos for finding the inverse of a square matrix non-singular. So I hope this is helpful to you. If you think like that, please do subscribe to my channel and don't forget to share it, like it. Thank you very much. We will meet again in the next video. Have a nice day.